SMB3 versus traditional block storage. File shares versus iSCSI versus Fiber Channel versus SAS. Who would have ever thought of running their SQL server with the files stored in a file share? Who thinks that's a bad idea? Come on, be honest. I know some of you are thinking, what's that moron talking about? Well, it's possible now. Dave mentioned earlier, SMB3, it's your file server protocol. It's quite ancient, and it's gone through a massive leap in Windows Server 2012. Huge leap. Originally, it was actually called SMB 2.2, so if you are using your favorite search engine to dig up information on this, you may come across SMB 2.2. It was renamed during the beta of Windows Server 2012, March of last year, to SMB 3. The changes are humongous, but two of the major changes are referred to as SMB multi-channel and SMB direct. SMB multi-channel is where Windows File Services and SMB3 can automatically start making use of the bandwidth that you give to a client server or a file server. So if you give it a nice big NIC, like a 10 gig NIC, it can fully utilize the bandwidth of that 10 gig NIC. Now for application traffic, that's important. It's like putting in iSCSI. If I put in iSCSI with 10 gig NICs, I want to use that full 10 gig. I don't want 5.3 gig utilization when I test the thing, when I hammer the thing. I want to have that full 10 gig because I paid a lot of money for those switches. SMB3 is designed to be able to do that. So 1 gig, yep. 10 gig, yep. 40 gig Roki, yeah. 56 gig InfiniBand, yeah. In fact, not only can it fill that single pipe with multiple parallel streams of data transfer, but it can automatically scale out to multiple NICs. Think of it as dynamic MPIO, if you want to get it through your head. So if I have 2 NICs on my client server and 2 NICs on my file server, my client server will quite happily use both NICs, and if one of them disappears, it'll quite happily go back to 1. If I give it a 3rd NIC, it'll use it. How difficult is it to configure? There's one setting, turn it off. It is on by default. If it finds the NICs, it will use them. So it makes it easier to configure and deploy than MPIO because there is no configuration or deployment. It's set up NICs and given IP addresses. That allows us to push through a lot of data. Now I've heard some anecdotes about people who are really testing the 10 gig end of things and providing multiple 10 gig NICs and then faster when you get into Roki, which runs at up to 40 gigabit per second, or InfiniBand, which runs at 56 gigabits per second. When you start pushing through that amount of data through a file server or an application server, the processor and Windows have to process those packets. The packets are coming through the NIC into the Windows networking stack, and that all has to be processed by the physical processor on the machine. That processor potentially is going to have a high utilization to process those packets, and Windows is going to introduce some latency to process the packets too. So what Microsoft did to alleviate that is they looked to the past, and they found something called Remote Direct Memory Access, or DMA. It's been around for quite some time, but it came and went. It was way ahead of its time. And it's back again in high-end network cards. Those network cards that really can cause issues because they provide so much throughput. So it basically bypasses Windows. So the processor isn't getting hammered, and Windows isn't introducing latency for the flow of packets. Windows will start the initial data transfer, packet, file opening, security stuff and all that, and then RDMA kicks in. If you were running Network Monitor on one of these file servers, you would see the initial handle opening sequence of SMB3, and then you would see nothing, because this is not TCP/IP. This is its own protocol, basically copying memory from one server over the network. And you'll find it on some 10 gig NICs, Roki and InfiniBand, and I'm forgetting one I can't remember now. iWarp, which runs up to 40 gigabits per second. won't find this on 1 gig NICs. At least now you won't. I think you would have back in 2007, but it wasn't really necessary back then. But when you think about this, now we're doing file server stuff with very low latency on potentially up to 56 gigabits per second. How fast is the fastest fiber channel? 8 gig? 16 you can get? Okay, so 56 gigabits per second versus 16. And I can use 2 or 3 or 4 of those InfiniBands if I'm mental and have tons more money than I know what to do with. So we can really push through data. From what I'm hearing, with a pair of 10 gig NICs, the network no longer becomes a bottleneck, your spindles do. You have to start looking at putting in SSD if you want to make the network the bottleneck. This is some crazy, crazy stuff. We can get serious throughput. Fast? Well, you guys actually saw this in the keynote at MMS, where they compared iSCSI versus SMB3 on the same back-end storage. So the same spindles, same physical stuff, same network between the client server and the back-end storage. iSCSI on one, file share on the other. And it was 1 gig networking, wasn't it? The file share was slightly faster than iSCSI. Remember I said earlier on that iSCSI was still using VHD and didn't use VHDX? I wonder why Microsoft didn't bother. Because the file share now runs faster than iSCSI on the same physical infrastructure. Who does not know how to create a file share? I hope to see no hands. How fast can this stuff go? Faster than you'll ever want. Trust me, faster than I'll ever want. Last year, TechEd Europe, they hit 1.2 million from inside a Hyper-V virtual machine when they ran a stress tool. 1.2 million IOPS is way faster than the most demanding database Microsoft were able to find on the planet. It was actually a record and is still a record. And that was from inside a Hyper-V virtual machine, stored on a file share. Now, admittedly, they were storing it on I think 40 SSDs, and they were using 3 InfiniBand network connections. But still, they were able to do it. And at TechEd North America, one of the Microsoft storage partners demos and some trial stuff, and they were getting transfer rates of 16 gigabytes per second over a file share. Gigabytes, not gigabits. That's 4 DVDs a second. And not that I recommend piracy or condone it, but that would be great for BitTorrent. For downloading ISOs that are legitimate, of course. So SMB3 is now Microsoft's strategy for the data center. Why? Well, simple. I've abstracted the hardware completely. I've got storage spaces, which abstract my physical disks. I don't need to know about how to configure RAID and stuff. And file shares, well, file shares, they're just file shares. Use cases. So we've got 3 that I know of so far that are completely supported. One is the Server 2012 Hyper-V quite happily will store virtual machines on a file share. They'll run better there than they will on iSCSI. You got the right networking, they'll run faster than they would on Fiber Channel or SAS storage as well. And you may see Microsoft constantly talking about 10 gig networking and all that. You can still do this with 1 gig networking. Microsoft tend to talk about the enterprise data center and the big public cloud stuff when they're talking about this stuff rather than the rest of us in the real world. Not that those worlds are any less real, just not for most of us. And of course we can use this for a cluster storage. So I can build a Hyper-V cluster and use a file server on the back end to store my virtual machines that are highly available. So I don't have to spend tons of money on that expensive SAN anymore. We can use a file share to store lots of websites. The IIS, I can build myself a nice big web farm that's network load balanced, have the websites actually stored and their configurations actually stored in the file share, and run the websites on all the web servers in the farm. Rather than having a website on 1 server or on 2 servers, just put them on all of them. And now I have huge capacity for scaling out each of my websites. It's an architecture, it's a possibility, you don't have to necessarily use it. And SQL Server. If there was anyone who would care about disk performance it is SQL Server. These guys have to be conservative. And they are supporting SMB3 file shares with SQL Server 2008 R2 and 2012. I didn't. We'll get there. But you've spotted the problem. Oh, we'll get there. You're jumping ahead. But you're right on spot though. It's like you're sneaking ahead on my slides. Okay, we'll get there, don't worry. You'll see it being set up. Okay. I'm not going to demo how to create a file share. To be quite honest, if you don't know how to do a file share, it is literally a file share. Create a file folder, share it out, permission it to some servers or some applications. If you can't do that, maybe tomato picking. Although it's a bit early in the year for that. Stone picking. I'm sure there's farmers who still pick stones. So this thing is just really important. Why? It's the future from Microsoft. It's actually the present at this point. Skills, they're readily available. Anyone with a basic amount of Windows skills can create file shares. It's software defined, it abstracts the hardware, and it's faster than block storage that we've been using for the last 15 years. And that makes this really important.